Let's look at something I really love in maths, which is times tables in disguise. That's what I call this anyway. It's my name for it. Other people might call it something else. So we know that 4 times 6 is 24, but you can do so much with this information. 4 times 6 is 24, and also 40 times 6 is going to be very, very similar. So 40 times 6, 40, it's still 4 times 6. This is 4 times 6 in disguise. So 4 times 6 is 24, and then I just place this 0 from the question, so it's 240. That's why I call it times tables in disguise, because inside 40 times 6 is 4 times 6 in disguise. Let's do another one. 400 times 6. Very similar, you might know the answer before I do this. 4 times 6 is 24. Place the 2 zeros from the question. 2,400. This is a great skill when you get good at it. It'll save you so much time in maths. Let's do another one. 40 times 600. Don't guess how many zeros get placed on. Count them carefully. So 4 times 6 is 24, of course. How many zeros in the question? Well, there's 1 here and there's 2 on this side. So altogether there's 3 zeros in the question. Place 3 zeros is 24,000. Commas go 3 from the end. Let's do a massive one. I know you like to see huge numbers sometimes. You can even do something like 4,000 times 6,000 in your head, really, because you just have to count the zeros. I know this is going to be 24 and 6 zeros. So 4 times 6 is 24. How many zeros were in the question? You can see there's 3 on each side. I don't even need to underline them, do I? There's 3 zeros on the 4,000. There's 3 zeros on the 6,000. So 1, 2, 3, 4, 5, 6. Commas go 3 from the end. Oh, there's the thousands comma, but here we also have the millions comma, which means it's 24 million.
When I do these times tables in disguise, I make the children, again, I think I'm a broken record when it comes to, I love partitioning numbers out. So let's go to, should we do 40 times 600? 40 times 600. How I make children write this out in their books is that I make them partition all the numbers out. So 40 is 4 times 10. Of course, I'm sure you can do this in your head, but this is great to kind of show how we move the numbers around to create the answers. 600 is 6 times 100. Now, what I get them to do first is identify which is the number that's going to be easiest to multiply last. Of course, it's going to be 10 and 100 because they are just literally adding digits at the end of numbers. What we want to do is we want to multiply the 4 by 6 first, and that would make 24. Have we finished the calculation? No. We still need to multiply these two numbers here, times 10 times 100. How many zeros do we have? As Mr. Saul said when we were talking about in the mental methods, we have 3. So the number would be multiplied by 1,000, which makes it 24,000.
Now time for decimal times tables in disguise. So I'll base it on 4 times 6. That's not decimals. 4 times 6 is 24. We can use that information. You can use your times table knowledge to do a lot of things with decimals, and this saves you so much time. Let's say it was 0.4 times 6. Well, it's like 4 times 6, isn't it? It's a lot like 4 times 6. It's a lot like 24. But this time we're counting decimal places instead of zeros. There's 1 decimal place here. There's none on the other part of the question. So 1 decimal place in the answer. So 4 times 6 was 24, but 0.4 times 6 is going to be smaller. It's just 2.4. This is actually, 0.4 is just a bit, isn't it? It's no whole ones. It's just a bit times 6. One of the most important things in maths to know is that times means of. So basically, a bit of 6 is 2.4. A bit of 6 is less than 6. It's only 2.4.
And some would think that when you're multiplying, the number will always get larger than either of the two numbers. When you have a decimal, like such as 0.4, 0.4 is not 1 yet. It's not 1 at all. So if I multiply 6 by 1, it will equal 1. So anything that is multiplied by a decimal number that's less than 1 would not be as large as the number you're multiplying by.
Yeah, it's unusual, isn't it? You know, I always say times makes things bigger usually.
Yeah.
Well, this is the usually part. That's why I say usually, because when you times by something less than 1, it doesn't work anymore.
Yeah.
It makes it smaller. So 0.4, this is going to get very small now. 0.4 times 0.6. Well, it's something to do with 24, isn't it? Because 4 times 6 is 24. This time we have 2 decimal places. And then we've only got 2 digits. And we need 2 decimal places. So they're both going to have to be decimal places, which means the point's going to go at the front. And it's 0.24. So it's a bit times a bit, and it's getting very, very small now, 0.24. And it continues in the same pattern. I need a bit more space. We could do 0.04. This is very advanced now. Probably starting to go beyond key stage 2 now, aren't we, Mr. Blom? With 0.04 times 0.6.
But it still follows the same structure and strategy. So you should be able to do this if you're following the steps.
1, 2, 3 decimal places, which means 3 digits after the points. I've only got 2 digits in my answer. I need 3 digits after the point, which means the point's going to go here, and I'm going to have 3 digits after the point. The only thing I can place here is a 0, placeholder, 3 digits after the point. It is 0.024, otherwise known as 0.024.
One thing I'd say about something like this is you wrote there 24, and you know that you have to move over 3 decimal places. Is what I would do is that if you're not 100% sure, create like an imaginary decimal point there, and then move it 3 times. 1, 2, 3, and that was be where the decimal point ends up going.
That's naughty decimals, isn't it?
It's very naughty decimals, yes. But as you can see, I call these the tunnels. I call these the tunnels, whereby there should be a representative of value in each of the tunnels. We've got 4 in that tunnel. We've got 2 in that tunnel, and we'll have to put a placeholder of 0 in that tunnel. You always have to have a value in the unit value, so that would be 0. So therefore the number would be 0.024. If I'm being naughty.
Now this is something that might not be for you, it might not be for everyone. This is where we have something like, it's times tables in disguise still, but it's got a big number like that, and then a small number like a decimal. I'm sticking to things that are like 4 times 6. But this is like 4 times 6, but it's 400 times 0.6. So what I do here is, I'll do 4 times 6 first, as usual, 24. What I do here, though, is go to the big number. There's 2 zeros to be placed, so it's 2,400. Then I'll go to the decimal and see there's 1 decimal point. So I need 1 decimal point in the answer. Turns out it's 240.0.
Mm-hmm.
What this question is 400 times a bit. You could switch them round, couldn't you? It could be a bit times 400, because in multiplication it doesn't matter which number is first. Mm-hmm. So a bit of 400 is 240. Let's do one more of these.
You could write on the top, even before you write anything, is above 400 you could write plus 2 and minus 1 on the other one.
Yeah, I guess that would work. Let's do another one. Let's do 0.4 times 6,000. So when I look at this question, times means of. Massive thing to know. Times means of. What we've got here is a bit of 6,000, which means the answer is going to be less than 6,000. Anyway, 4 times 6 is 24. I'll go to the biggest number first. There's 3 zeros to place. 1, 2, 3. I'll go to the small number. There's 1 decimal place to put in. 1 decimal place goes in. So a bit of 6,000 is 2,400. And by saying that at the end, I'm checking myself, making sure it makes sense.